Guess who's back? Back again. Okay, function question, bitches. They're gonna ask a question on functions, and I've gone through all the past papers and practically predicted it for you. So again, we have the content which you need to understand to answer this function question, which I'll run through in a minute. But here, they basically ask it in a few ways. They give you a function, which is a trig function, and I've grouped all of those type of questions here, and they ask you to do stuff that with the trig function. They can ask you to complete the square, so they'll give you a complete the square function, and I've grouped all of those type of exam questions together there for you. So you can see they all start off with a complete the square function, and you have to do stuff with it, find domains, ranges, inverses, composite functions, all that stuff. And another thing they can do is they can give you two functions, and you have to do a bunch of stuff with that. Maybe you sketch them, whatever. There's a bunch of things you can do with it. And I've grouped all those type of questions together. And then we've got other ones. So just, other common questions, which is just, a few different common ones, which are kind of similar as well. But they're all grouped for you, and they're all answered for you below. So you've got all the answers for all of those questions. So I've grouped them for you in the different ways that they can ask this function question. So you know exactly all the ways that they can ask it. I'm not really going to go through this content. You should go through this and understand this. But basically you need to learn. We're just going to do examples in this video, because that's the best way to, I think, to go through this. Basically what you need to know, you need to be able to plot trig functions, and I give you examples of when you change different variables, you change how you can change the amplitude, the phase, the shifting it up and down, shifting it horizontally, all that stuff. I give you all those examples. You need to be able to plot the inverse. You need to find and plot inverses of functions, and I show you that. It's just a reflection through the y equals x axis. So just go through and make sure you understand that. You need to be able to find composite functions, which you should know about. You need to be able to find domains and ranges of functions, and inverse functions and composite functions, and that's all given to you there and explained to you all there. And you also need to be able to find the complete the square of a quadratic. Okay, so let's just do some questions to get an idea of how they ask this question. So I'm going to do 3 good representations of this question in this video. So let's just go straight into it. So you'll see that how they like to ask it. They like to give you a function, and then they ask you to do things on those functions. So in this one, they give us a function. So this is the trig one that they sometimes give you. So f of x equals 4 sine x minus 1 for the domain of, so this is valid, this function exists for minus pi over 2 to pi over 2. So the first part is to state the range of f. Well, we're given the domain of f of x, so then we can find the range of f of x, and the range is just where the f of x goes from. So what's the lowest to the largest value of our f of x takes for this domain. So let's just plug in some of these values. So we plug in the lowest quartile, whatever you call it, lowest point, which is going to give us 4 sine of minus pi over 2 minus 1, and minus pi over 2, well, that's just going to be minus 1, so you're going to get 4 times minus 1, which is minus 5. And then we'll plug in the upper range, so the highest one, which is 4 sine of pi over 2 minus 1. Well, that's just going to be 4 times 1, because sine of pi over 2 is 1, minus 1, which equals 3. So the range of f of x, therefore, goes from minus 5, so it's greater than or equal to minus 5 and less than or equal to 3. So that's our range of f of x. Cool. Now II, find the coordinates of the points at which the curve y equals f of x intersects the coordinate axis. Well, if our y equals 4 sine x minus 1, well, the coordinate axis is your y-x, well, you can say that this curve here, this thing, so you know, this curve intercepts, so it intersects the x-axis when y equals 0. Yeah, when y equals 0, this intersects the x-axis, and it intersects the y-axis when x equals 0. And that should be pretty clear. So we just put these two things in. So when x equals 0, we get y equals 4 sine of 0 minus 1, which equals, well, sine of 0 is 0, so this is just minus 1. So one of our points, one of the intersects of the coordinate axis is at 0 minus 1. And another one will be when y is 0, so that will equal this. So therefore that gives us 4 sine of x equals 1. So sine of x equals a quarter. So our x will be the inverse of that. And if you just plug that into your calculator, you will get, where's my calculator? Over here. You will get shift sine of 1 over 4. So you'll get 0.253 radians. So 0.253 radians. Rads. So the second point where it intersects the coordinate axis is at 0.253, comma 0. So we have our 2 points there. We have 0, negative 1, and 0.253, 0. So those are the 2 points of intersection of the coordinate axis. Okay, let's keep going. So I sketch the graph of y equals f of x. So we have this here, 4 sine of x. And on the worksheet, I show you in the fundamental content exactly how this works. But basically, you know, well, what I like to do whenever I have to sketch one of these things is I just draw out what does a sine graph look like. Well, a sine graph looks like that. And we know it's between minus pi over 2. It's between minus pi over 2 and pi over 2. This is yx. So it's going to have an amplitude of 4, and it's going to be shifted down by minus 1. So if we draw this here, let's call this pi over 2. Let's make it a bit closer. Let's call this pi over 2. We can call this minus pi over 2. Well, it's shifted down negative 1, so it's going to be passed through here instead of at 0. And its amplitude is 4, so it's going to go up 4, which will go to, that's 3, and it will go down to minus 5. So it's going to look something like that. That's pretty poorly drawn. It's going to look something like that. So it goes up to 3. It's meant to be at 3. Oh god. Goes up to 3 and down to negative 5. So it's going to look something like that. Okay. I think we've got one more question here. Okay, so IV. So let's just move this down a bit here. So IV is obtain an expression for the inverse of f of x and state both the domain and range of it. So you can see that. So I'll just rub this out so we can have some room for this next question. So this is IV. So if f of x equals 4 sine x minus 1, well, if we want to find our inverse of x, we need to just change our x for f of x. So we go f of x plus 1 equals 4 sine of x. So therefore sine of x equals f of x plus 1 over 4. So therefore x equals the inverse of sine of x of f of x plus 1 over 4. So our inverse of f of x equals this. And they ask that every year for you to find an inverse. And then it asks to find the domain and range of this. Well, if you look on my worksheet, and you should also just know this, that, you know, the domain of the inverse of f of x is the range of f of x. And the range of f of x is from -5 to 3. So that means the domain of inverse of x, f of x, is from -5 to 3. And the saying goes that the range of the inverse of f of x is the domain of f of x. And the domain of f of x is from -pi/2 to pi/2. So that means that the range of our inverse of f of x goes from -pi/2 to 2. So that's your answers. Okay, cool. Let's just move on to the next one. So this is the other archetype, the other way that they can ask is they'll give you a complete the square function. So you'll hear your I to complete the square, so you've got to put it in this form. Well, what I do is I'd first of all just take it as a negative, and this becomes this, right? And then I'd say, well, x minus 3 squared, right? And I'll just go up here. Well, x minus 3 squared is going to give us an x squared minus 6x plus 9. So to get it to the plus 5 on the end here, we're going to have to make it minus 4, which will give us the x squared plus minus 6x plus 5. So there's a minus 4 on the end here. So therefore we get, if we expand it in, the negative x minus 3 squared plus 4. So that's it in this form. So where our a is -1, our b is -3, and our c is plus 4. Cool. So if f of x now equals this, which is our minus x minus 3 squared plus 4, for x is greater than or equal to m, state the smallest value of m for which f is 1 to 1. Well, this is going to look something like this. You know, you're going to have some parabola. And remember, a function is 1 to 1 is if when we put one input in, we get one output. So, you know, here, if we put in, let's say f is 1 here or something, well, we're getting 2 outputs here for our one input. So the point in which the smallest value of m, so the point in which it's 1 to 1, is past this vertex point here. We call it xv and yv, past this vertex point, because when the function is defined past this vertex point, when we put one input in, we get one output. If it was defined between here and here, we get 2 outputs for our one input. So what's the vertex point? Well, the vertex point occurs when x equals 3, because that makes f of x at its greatest. So that means our m is 3. So it's 1 to 1 for x is greater than or equal to 3. Hope that makes sense. And then finally, I. For the case where m equals 5, find an expression for the inverse of x and state the domain of the inverse. So m equals 5, so we have f of x equals, I like to rewrite them out just to make sure I know where I'm at before I start the question. For now, m is 5, so our m is 5, so it's greater than or equal to 5. So f of x, so now to find the inverse, we're going to go f of x minus 4 equals minus x minus 3 squared. Let's move this down. Then we'll divide through by -1. We get minus 3 squared equals 4 minus f of x Then we get x minus 3 equals the square root of 4 minus f of x plus or minus the square root. So then x equals 3 plus or minus the square root of 4 minus f of x. So the inverse of x equals 3 plus or minus the square root of 4 minus x. Now, you've got to be careful here because our domain of f of x is greater than or equal to 5. So that means that our range of f inverse of x has to be greater than or equal to 5. So that means that it's only a plus. Because if it was a minus, then it would be less than 3, which is not greater than or equal to 5. So the only part of it that we're interested in is the plus 3 plus the square root here. Cool. Now it wants us to find the range of, what does it want to find? It wants us to find the domain of the inverse. Well, we can just say that because our range from here, the domain of this is, well, we know that our range of our inverse of x is going to be greater than or equal to 5. So we know that this is greater than or equal to 5 because the domain of f of x is greater than or equal to 5. So if we just put that in here, we get 3 plus the square root of 4 minus x is greater than or equal to 5. Right? So then we get the square root of 4 minus x is greater than or equal to 2. Then we get 4 minus x is greater than or equal to what? 4. Then take that over, we get x is less than or equal to 0. So that's our domain of the inverse. You could also have just found the range of f of x, and that would have been the domain of the inverse of f of x. Okay, and finally, let's do this one, which is really good for us to try and understand the range and domain of composite functions and finding composite functions. So the first one gave us a good archetype of trig functions and using that to find ranges and domains and all that other good stuff. The next one was about completing the square and finding ranges and domains and inverses and all that stuff. And now this is a really good question to help you understand composite functions. So, and I describe all about composite functions and how to find domains and ranges of composite functions on the worksheet. So, we're given here that f of x equals 3x plus 1, and that's defined for x is less than or equal to a, where a is a constant. And we're also given that g of x equals minus 1 minus x squared for x is less than or equal to negative 1. So, find the largest value of a for which the composite function g of f can be formed. Well, g of f of x. So that's the same as g of f of x. So the input is f of x. Well, g of x, for g of x to be valid, it's valid for, exists for x is less than or equal to negative 1. So the input into our g of x has to always be less than or equal to negative 1 for it to be formed, for it to be valid. So that means that in this, our input is f of x. So that means that our f of x has to be less than or equal to negative 1 for this function to form. Otherwise, it's only because it's only valid for when the input into g of x is less than or equal to negative 1. So that from there, then we can find a, because then we can say that, well, f of x is 3x plus 1. That means that this has to be less than or equal to negative 1 for this to be formed, for this composite function to be formed. So then 3x is less than or equal to negative 2, and x is less than or equal to negative 2 over 3. So for g of f of x to be formed, x must be less than or equal to negative 2 over 3. And that's because of the restraint on the input into g of x must be less than or equal to -1. Okay, hope that makes sense. So for the case where a equals -1, so I like to rewrite it. So we've got f of x equals 3x plus 1. And now a is -1, so this is for x is less than or equal to -1. And we also have g of x equals -1 minus x squared for x is less than or equal to -1 also. Okay, so now solve this equation. We want to solve this equation. Well, f of g of x equals, if we put g of x into f of x, we get 3g of x plus 1, which equals 3 minus 1 minus x squared plus 1. So it gives us minus 3 minus 3x squared plus 1, which gives us minus 2 minus 3x squared. So that's our f of g of x. So let's then plug this into here. Well, we're going to get minus 2 minus 3x squared plus 14 equals 0. Well, that's going to give us minus 3x squared plus 12 equals 0. So we take that over, we'll get 3x squared equals 12. Yeah? And then we'll get x squared equals 4, and then x equals plus or minus 2. Now, again, you've got to be careful here because we have two solutions. But are both of those two solutions valid? Well, we know that our input function here, g of x, because like I say in my worksheet, the domain of our composite function is dependent on the input function of our composite function. So f of g of x, well, g of x is restricted by x. The domain of g of x is x is less than or equal to -1. Well, there's only one of these solutions in which x is less than or equal to -1, and that's the -1. So the answer is in fact only -2, not +2. I hope that makes sense. If that doesn't make sense, you should really go away and learn about composite functions and domains and ranges of composite functions. Okay, that's that done. And then finally, find the set of values for which x satisfies the inequality. So I. So g of f of x is less than or equal to -50. Less than -50. Well, let's just find g of f of x first. And that just equals to minus 1 minus f of x squared, minus 1 minus f of x squared, which equals minus 1 minus 3x plus 1 squared. 3x plus 1 squared. Okay, and we want to know where this is less than or equal to -50. Well, we just take this over. We get minus 49. And we can take this back over here if we wanted to. Say minus 3x plus 1 squared plus 49 is less than or equal to 0. We want to know where this is less than or equal to 0. Oof. It'd be nicer to just do it like this actually. If you say, well, if you just take it over here, you can say 3x plus 1 squared minus 49, take it over, is greater than or equal to 0. Where is this greater than or equal to 0? See, I've just taken it over there and then sort of switched it. So where is this greater than or equal to 0? Well, let's just solve this. So this is 3x plus 1 squared, and we can just say minus 49 equals 0. So then we can say equals 49. So we get 3x plus 1 equals plus or minus 7. So therefore x equals, we get minus 8 over 3, and x equals minus 6 over 6 over 3, which is 2. So we get 2 solutions. And then if we just look at this graph here, so we can call this 3x plus 1 squared minus 49. Well, where is this? And this is 2, and this will be minus 8 over 3. Where is this greater than or equal to 0? Well, it's greater than or equal to 0 here and here. So this is greater than or equal to 0 when x is less than or equal to negative 8 over 3, and when x is greater than or equal to 2. Now, again, you have to think, well, are both of these solutions valid? Well, what is our domain of f of x? Because that affects the domain of our g of f of x. And our domain of f of x, remember, is x has to be less than or equal to negative 1. So that means that we can't have this solution. So there's only one answer, and the answer, x for this inequality here, is only valid for x is less than or equal to negative 8 over 3. Okay, cool. So that is 3 great representations of the different ways that they can ask this question. So then we've got, so download my worksheet, and if you need catching up on anything that you don't understand in regards to the information and understanding you need for this question, then run through the fundamental content. You've got some good stuff here on finding the domain and range of composite functions. And then we've got all of these past paper questions grouped together in similar ways. So we've got all of the ways that they ask here when it comes to trig functions. We've got all the ways they ask when it comes to completing the square function. We've got all the ways that they ask when it comes to when they give you 2 functions. And we've got other ways, like slightly different ways. See, these are similar here. We've got these 2 that's similar here. So I've picked ones that, you know, that are common and come up a lot. And I've gone through and answered all of those. And I checked them all to make sure they're all right, and they are all right. And so you've got all of my personal answers there, which you can go through. Okay, that's a great resource. Download that and you'll do mean in the exam for the function question. Thanks a lot. Peace out.